1 second. That's how close the most powerful rocket ever built came to leaving the pad before it suddenly refused to go. The engines were already lighting when Starship's own computer slammed on the brakes and killed the launch. So what did it see in that final second that we didn't? The strangest clue is this. 6 days earlier, this exact booster had lit all 33 of its engines and passed. Let's rewind to Thursday evening at Starbase. The countdown for Flight 13 was ticking toward a 5:45 liftoff. At about 3 seconds out, all 33 engines on the Super Heavy booster began their startup, the split second where each one roars to life. But some of them didn't light correctly. And before the clamps holding the rocket down could release, the launch computer called the whole thing off. The engines that had started were shut down, the fuel was drained, and the entire stack stayed bolted to the pad. SpaceX came within roughly 1 second of releasing the biggest rocket ever built and chose not to. That's what makes this strange. Just 6 days earlier, on July 10th, SpaceX had strapped this same booster down and fired all 33 engines at once in what's called a static fire, a full-dress rehearsal of ignition. It looked clean. So how does a rocket pass a 33-engine test, then fail to start those same engines 6 days later on launch day? That is the question everything now hangs on. The uncomfortable answer is that a static fire and a real launch are not the same thing, even though they look almost identical. On launch day, the booster was carrying the full Starship stacked on top, which changes the loads and the plumbing. The propellant can sit at slightly different temperatures and pressures. The engines get chilled down on a different schedule. The pad may be set up differently, and the flight software may hold the engines to stricter limits. The countdown even paused briefly near the 1-minute mark, which can shift temperatures and pressures around. Any one of those small differences can turn a clean test into a failed start. A component can pass one ignition and stumble on the very next. Then there's the question of how many engines actually failed. The live webcast graphic appeared to show 29 engines lit and 4 dark. That sounds precise, but SpaceX has only officially said that some engines failed to start. A public graphic is a simplified picture, not a full readout of what each engine was doing in its final milliseconds. And this is where it gets even murkier. SpaceX says it is replacing 2 Raptor engines, not 4. Elon Musk framed it as swapping them out to be confident of a good flight. The likeliest explanation is that the count on screen and the count of truly broken engines are not the same number. 2 engines may have genuinely failed, while the other 2 indications came from the abort itself or from one shared problem rippling across neighbors. And replacing 2 engines doesn't prove those 2 were the culprits. Pulling them can just as easily be a play-it-safe move, getting suspect hardware off the rocket while the removed engines are taken apart and studied on a bench. Now, for the part that should actually reassure you. All of this happened while the booster was still bolted to the launch mount. Starship is clamped down while its engines light, a bit like revving an engine hard with the parking brake locked before you ever decide to move. Liftoff only happens if the computer decides the whole system looks healthy. It didn't, so it never let go. Think about what that prevented. A rocket lifting off without enough thrust, engines pushing unevenly right above the tower, or an engine failing violently as the vehicle cleared the pad. The system ran into a serious problem at the single safest moment it could have and did exactly what it was built to do. So what now? SpaceX has to pull and replace those 2 engines, inspect the other 31, check the pad and the ground systems, and prove the rocket is healthy before trying again. The big unknown is whether it needs to repeat that full 33-engine static fire first, and that one choice will quietly tell you how serious this really was. If the fault was cleanly isolated to 2 engines, SpaceX can swap them, run its checks, and fly again fast. If instead the trouble came from something shared, the fuel system, the software, the pad, or the ground plumbing, then another static fire becomes far more likely, and the delay stretches out. One thing worth clearing up. Because the rocket never left the ground, there was no accident, and as of now, no new federal investigation to grind through. The FAA had already closed its review of the previous flight before this attempt. So the wait is mostly about engineering and the usual launch logistics, not a long safety probe. Musk has said the most likely timing is early next week, though no date is locked in yet.